scenarios. So again, like with every math thing that I do, if you've taken very many math classes with me, you've seen me do this a million times. I always say that the thing you really have to have is you have to have an ability to identify what the problem is that's in front of you. And when it comes to percent applications, it's more than some of your identification processes where you're really having to really drill down and think about what is it, because it's more than saying, oh, that's a percentage word problem. It's going to be more like which type of percentage word problem. And this will allow you to apply the correct process, which is of particular difficulty when it comes to percent applications. This is one of the harder areas to identify the problem type. Identifying the problem type is something that whether I tell you to do this in proportions class, this class, or another class, you should never, ever drop that. That is a thing that you always want to do no matter what happens. So essentially what we have is a situation where identifying a very specific element of the problem will allow you to figure out, do we multiply, do we divide, do we set it up like this, do we set it up like that, and so on. So let me zoom this in a little bit as much as I can. We are going to disregard scenario 4 for now. We'll come back to it later today. So we're going to look at 1, 2, and 3. Now, when we look at these, we're going to think about, so how do we know we have a 1? How do we know we have a 2? How do we know we have a 3? And then we will practice identifying them first. Then we will practice really putting them into practice. I'm going to draw a line right here. And I'm going to draw another line, whoops, right here. And the reason that I'm doing that is I've always felt like scenario 1 and scenario 4 are very unique. I've always felt like scenario 2 and 3 have a lot of parallel and they're hard to tell apart. So we'll start with one of the easier ones, which is scenario 1. So a scenario 1, and just as a disclosure so that you're not hunting for this somewhere, these are numbers that I've made up. So the essence and the point of what we're doing is not the actual number, although that's a great way to keep it in your head more easily. But ultimately, whether you used 1, 2, and 3, or whether you named them Bob, George, and Sam, wouldn't really matter. Because ultimately what we're doing is we're looking at the type of info given in the problem, the type of question asked in the problem, and how we would assemble everything all together. Now, this all is based on something that I'll write at the bottom, and you can do that as well. You won't need the bottom of this page for anything. So basically, if we really simplify the world down to something as simple as 1 fraction, everything in the percentage realm is a part over total equals percent. It's not exactly that way, so I will clarify something. You won't get a percentage by doing this. What you'll get is a decimal that has to be transferred to a percent. I do a class that does talk about those conversions, although I will clarify the couple of details that you need to know about that to succeed in this class. So anytime that you take a part and you divide that by a total, what you get is a decimal. The decimal can then be changed to a percent by moving the decimal space 2 units to the right. So a percentage is a fake number. It's not a real number. It doesn't come out of a real equation. It's something that we change a decimal into to make it a little more relatable. So decimal numbers are between 0 and 1, for example, 0.2. We don't really relate to 0.2. We can't really get ourselves a good mental image of 0.2. But if we go like this and we turn that into 20, now we can see a 20. 20s make sense to us. So percentages are fake numbers that are converted from decimals to give us a number between 0 and 100 to deal with, instead of having a number between 0 and 1, which is less relatable. So when we think about part and total, those are 2 elements that you may find in your problem, or you may find that you're being asked about one or both of those. So when we look at a scenario 1, 2, and 3, what we're essentially looking at is, like with every math problem, one of these things will be missing. We can't solve anything if all of the possible pieces are given to us. So something is always missing, or there is no problem or no question to be answered. Which of these three elements is missing is what decides if it's scenario 1, scenario 2, or scenario 3. That's the reason I don't go over scenario 4 right off the bat. There are not 4 possibilities for what's missing. So a scenario 4 problem is very different. Because it's very different, it's usually very identifiable as well. So we toss that on at the end of this class. So we're going to deal with scenario 1, 2, and 3. In each of those, one of these things is going to be missing and the other 2 are going to be present. As you look at the strategy sheet that you have in the front of your packet, you'll see given, looking for, and then an instruction as to how to get there. So the givens are very important. You always want to read a problem and think, all right, what did they give me? Did they give me a part and a total? Did they give me a part and a percentage? Or did they give me a total and a percentage? A scenario 1 will be fairly obvious because they're going to give you 2 numbers, 2 regular, plain, everyday numbers, not numbers that have a percent sign with them, just regular numbers. Those numbers are the part and the total. What you're going to be looking for, so what they're going to ask you to find, is going to be a percentage. So that makes this pretty obvious. It will stand out from the other 2 because you might glance down and notice the other 2 will both have a percent given. That makes the other 2 much more similar to each other, and it makes one much more unique. So that would be something like saying 13 out of 30 club members are female and asking what percent. So you'll always see what percent of the club is female. Now this would be a straightforward version of the question. So you'll notice when you read one of these that there's not a percent, so you don't see a number next to a percentage. And secondarily, you'll notice that they are asking you to find a percent, and in place of that, they have 2 normal looking numbers given to you. All you have to do if you discover that you have a scenario 1 is take the part and divide it by the total, or take the top and divide it by the bottom. In this case, 13 would be the part because they're saying 13 out of 30. They're making it clear that 30 is the total number of club members. 13 is the number of female club members. If you take 13 and you divide it by 30, 13 divided by 30 is 0.4333, and so on. Now we're going to change that to a percentage because we aren't asking for a decimal, we're asking for a percent. Changing to a percent is always a matter of moving 2 spaces to the right. So 43% are female. So since 1s are very easy to recognize, you have to watch out for tricks in another arena on these. They're not going to trick you with the problem because the problem's pretty simple. Where they're going to trick you is they're going to say something like 13 out of 30 club members are female. What percent of the club is male? And they're going to give you a different question than they gave you piece of info. So the difficult scenario 1s will present as though they're easy, but you'll notice that the question asks for a quantity that has not yet been given. So we know how many females there are. We don't know how many males. We do have enough info to find out because all we have to do is take 30 minus 13, and that will tell us what we have left over. So if 13 of them are females, then 30 minus 13 says that 17 of them are males. Males would now be your part. 30 remains your total. So that's not difficult by any means. It's just a matter of noticing that that's what they did. So those questions really only get missed when you don't notice them. Now I'm going to round this as well. You should be very cautious about rounding. You should never round unless the problem indicates that you should. The problem will indicate whether or not you should every time, because even if they don't say anything about rounding, you can look at the answer choices and see, did they round up to the next nearest number? Did they round up to the next whole number? Or did they keep a couple of decimal points in place? That will tell you what you should ultimately end up doing. So that's scenario 1. Scenario 1 is a lot different from all of the others than scenario 2 and 3 are with each other. So in both scenario 2 and scenario 3, you will immediately notice that there is a percent given. So one of your two pieces of info that you already have will be a percentage. If one of your givens is a percentage, that will make these look a lot more similar, because the big defining characteristic of scenario 1 is it doesn't have a percentage. That makes it much more obvious that you're dealing with a scenario 1. So in a 2, you're given a part and a total, or in a percent. In a scenario 3, you're given a total and a percent. So the difference between the two is the regular number that they give you. The one regular number is a part in a scenario 2, and it's a total in a scenario 3. So all we really have to do is understand the words that they give us in the question. So the words in the question will tell us everything that we need to know. So if you're given a part and a percent, it will read one of two ways. So let's do 13 is 50% of what number? I would strongly recommend writing both of these down, because even once you learn how to tell a 2 from a 3, a lot of people have a hiccup when they rearrange it. So this is one way they could ask the question. Now I will ask exactly the same question. Percent in the front. So 13 is 50% of what number, or 50% of what number is 13. That says the same thing, but they're in opposite orders. You can't glance at this and tell it's a 2. You also can't glance at a 3 and tell it's a 3. What you can do is you can read the question and you can identify the fact that it's telling you that 13 is already 50% of something. So 13 is 50% of what? So that means that we already took something and we took 50% of that something, and what we got was 13. So 13 already represents 50%. What we don't know is what was the 100%. What did we take 50% of that turned out 13? This is written the same way. Both of them say that 13 is 50%. They say it in one direction or the other, rather than asking you to find 50% of 13. Now, if you had the exact same numbers with the sign on the same one, and you had it in a scenario 3, it would say, what is 50% of 13? Or it would say 50% of 13 is what? So it's the same numbers, and the percent sign is still with the 50. These are asking you 50% of 13. These are asking you what 13 is 50% of. So they are exactly the opposite. You're reliant on understanding the story to figure out the answer. Now let's look at how the math works for both of these. If you have a part and you're looking for the total. You're going to take your part, so in this case 13, and you're going to divide it by the decimal that represents the percentage they gave you. So 50%, if you change it to a decimal, is 0.50. And you're going to take the 13 and divide it by 0.50. That will make it 26. If you take a decimal that is smaller than 1 and you divide it into a number, it will make the number bigger rather than smaller. So division works the opposite with a decimal of how it works normally. Normally, we would divide to cut a number down. If the number you're going to divide by, though, is less than 1, as it typically will be, that will actually make your answer bigger. So by getting 26, what we figured out is if you had 26 and you took 50% of it, you would have gotten 13. So if we reverse that and we say 13 is 50% of what? 13 is 50% of 26. If we do the same thing with our scenario 3, we multiply us to find 50% of 13. To do that, we take 13 and we multiply by 0.50. When you multiply and one of your multipliers is less than 1, it will also have the opposite of its usual effect. It will make the number smaller. So if you took half, 50% of 13, you would find out that it's 6.5. So as similar as the wordings and setups of these questions look, their answers are quite a lot different. The bigger the number, the more variation there will be between applying a scenario 2 and a scenario 3. So always try to check back once you get your answer and make sure that it makes sense, because you should know on some level whether you were trying to make your number bigger or smaller. These are the 3 that we're going to deal with for now. The hardest worksheet you will do today is the next one in your packet, which says CUDA Software Infinite Pre-Algebra % Word Problem. Should be your very next page. So I often have people tell me, well, I just hate word problems. I'm just really bad at word problems. Now, ironically, this worksheet is called % Word Problems. I would beg to differ. What I would consider a word problem is what you'd see on the next page, where there's really a lot of words describing the problem. At least when it comes to percentages, and I argue that it's always the case, I feel like more words are better because they give you a story, they give you a context, and they solidify your thoughts. So to prove that and to hopefully help you like word problems better while also getting a bit of difficult practice in, I am going to have you identify the scenario type in word problems that have very, very few words. Personally, I've always thought a story gave you a bit more grounds in every area, but especially percents, because the less they say, the harder it is to figure out if the number they gave you is a part or if the number they gave you is a total. So using the very minimal words provided here, all I want you to do is just label 1, 2, or 3. So pull apart that front page if it helps to have it sitting next to you. And all I want you to do is decide for each of these, are they scenario 1, scenario 2, or scenario 3? You don't have to do the math right now. We're going to go through 10. So make a little line, because when you get to 10, I'm going to tell you what the answers are and I'm going to explain them. And then I want you to do the 11 to the end after your first explanation. That way we can hopefully curb any issues that you're having or anything that you're doing wrong. So just do through number 10. And in a few minutes, I will go through and show you where the wordings are that tell you the story that you needed to tell. And we'll have you do the second half. Be very careful with these. So look at them a few times. And if you do get to number 10 and I haven't started back up, go back across them and really check them, because most people get a lot of these wrong on the first pass through. So see if you can get them right on the first pass through by checking really carefully for the story to be told. Hopefully you had a chance to make it to all those. I'll keep us moving. So the first one is a scenario 1. You probably felt like the scenario 1s were fairly easy to identify for the most part. Here and there, you might have thought one was a little different because it had like a decimal in it and it made you think it was a percentage. But most likely you came to the conclusion that number 1, 3, 5, 8, and 10 ones. Then you're left with the ones that have percentages in them. And you know that the ones that have percentages in them are either 2 or 3. And that's a really hard determination to make. Now on number 2, it says 81 is 56% of what? The question is always, are they telling you that the regular number, which in this case is 81, are they telling you that is 56%, or are they asking you to find 56%? It very clearly says 81 is 56%. So that is a scenario 2. 81 is the part. Now, number 4 is worded in the opposite way. So what I tend to notice if you got number 2 right, you got number 4 wrong. And if you got number 2 wrong, you might have gotten number 4 right. Why? Because people assume when it's written backwards that it's the opposite scenario. But they can really arrange things however they want. So this says 17% of what is 156. Again, it says 17% of what? And it says that whatever that is, it is 156. So this is also a 2 because it's telling you that 156 is 17% of something unknown. So again, 156, even though it's rearranged, is still being addressed as the part. Number 6 is a scenario 2 as well, because it says that 79.9 is 99% of something. Number 7 is again a scenario 2. If nothing else, it's a little weird to have that many 2s and no 3s. If that began to throw you off, the way I would address anything like that and continuing on through all of the math problems that I give you is never assume you're right or wrong based on trends, because a lot of times they write those in to see if it scares you. The only 3 we have is 9. 30% of 117 is what? Now, you might have noticed the trend of the word is and the word of. Again, don't recommend following a particular trend, especially when it's a word matching trend. So I don't recommend just being like, oh, I see the is, that's a 2, because you're just kind of assuming based on how something looks. However, the word is does correlate to a scenario 2 because it always says that the number is 89.3 or is 156, and that gives you a hint that that's the part. The of typically corresponds to the total, but again, I strongly encourage you to always use the story. Let the problem tell its story and adhere to the story that the problem tells. Now, take anything you glean from that and do the next 8 of them. I won't give you quite as much time because you'll probably fly through those fairly quick. And then we will go on to the real word problems, which will probably seem like a bit of a break. So try those, and I will go over them in a minute. So number 11 is a scenario 3. It's asking you to find 120% of 118. Number 12 is a 1. The 1s are beginning, I'm sure, to stand out quite a bit. Number 13 is also a 3. It's asking for 270% of 60. Number 14 is a 2. It says that 73% of something is 156.4. Number 15 is a 3. 87% of 41 is what? So you're taking 87% of 41. The last 3 are all scenario 1. If you struggled with that, if you missed a lot of those, you're completely normal. That happens a lot on that worksheet. I've discovered that that worksheet is a great place to really challenge yourself to use and figure out scenarios, but it's also pretty tricky. And the reason it's tricky is it doesn't have words for you to use as reference points and to decide where you are. So now let's look at some real word problems, and these to a lot of people are a welcome break because there's a bit more of a story being told so that you can match it up to a story. Let's do number 1 through 6 and then 9 and 10. The scenario you believe is being used. Attempt to do the math as well. So I always identify the scenario over here on the left before I ever start. So look at the story, decide, do you have a part and a total? Do you have a part and a percent? Or do you have a total and a percent? What scenario are you in? Attempt to do the math, but at least have your scenario identified if you have any trouble with the math on any of them. And then I will go through what scenario they're in, how we know, how to set up the math, and what the answer is in a few. So this is just kind of a nice free time to look at all these, really analyze them, think about which scenario, and then attempt the math. And I will go over them shortly. So this whole page, except the 2 crossed out, and then also don't do 11 because that's a scenario 4. Give you a couple more minutes. If you are done, you can text me and let me know. That's several problems. So if I do get everybody saying they're done, I'll go ahead. Otherwise, I'll give a couple more minutes. So hopefully everybody got a chance to get through there. I will start going over them. You can catch up if you did miss any of them as I go through. The first question, I'll erase these so you can see, is a scenario 1. The only tricky thing is 13 is the one that's the part. Take 13 divided by 65. And that is 0.2, which will turn into 20%. Don't forget to change those 2%. A scenario 2, they're telling you that 42 is 60% of something. So if we take 42 and we divide it by the decimal that represents 60%, which is 0.6 or 0.60, we will get 70. Number 3 says a softball team won 95% of 120 games played. How many games is that? That is a 3 because they told you that they won 95%, but they said they played 120. So played is not the same type of number as won. A scenario 3 will cause us to turn the percentage into a decimal and then multiply. So you'll take 0.95 times 120. And that will give you, hold on, 0.95 times 120. Why is this not working? There we go, 114. By the way, as a side note, if you haven't been already, it's a great plan to do at least some, if not all, of your math practice with your computer calculator, because these computer calculators are obnoxious. They do some crazy things. They'll think you hit buttons when you didn't, or they'll think you didn't hit a button when you did, and you will be forced to use one of those on the test. So if you've never practiced with a clunky computer calculator, you need to do that at least partially while you're practicing so that you're used to it. Number 4 is going to be a scenario 2. So at Big City School, 4,248 students ride mass transit to school. If this number is 90% of school enrollment, so it says that it is, then how many students are enrolled? And that's 4,248 divided by 0.9. And when you practice on it, depending what kind of technology you have, make sure you're actually taking a mouse and clicking it. That comes out with 4,270. So mine's a touch screen, which is how I'm able to write on it all the time. But I make myself use the mouse and actually click the buttons. And it is obnoxious. It's a terrible process. So that is a good thing to be practicing. Number 5 says if 12 out of 21 students are girls, then what percent of the class is girls? So that's a scenario 1. This one happens to be written where the same number that they gave you as the part is also what they're looking for, but always be careful because it's very easy for them to ask you what percentage is boys instead of girls. 12 out of 21, my bad, hold on. 12 out of 21 is 57% should be your answer. And then a tool that regularly sells for $18.50 is on sale for 20% off. What is the sale price? This one's got a couple of tricks to it. It is a 3, and it's a 3 because ultimately what we need to know, at least to start out, is what is 20% of $18.50. Now, that's not the only thing we need to do. We also need to take that 20%, whatever we find that to be, and subtract it out of $18.50. So $18.50 times 0.2 tells us that 3.7 is 20% of $18.50. Couple of point outs here. There's more than one way they can ask a question like this. The 2 main questions that you would see is what is the sale price, or what is the discount? 2 very different questions. Both of them would be scenario 3, but one of them will require an extra step. This one wants to know the sale price. When you take 20% of $18.50, what you get is the discount. Now, another point out is I got 3.7. That's quite literally what my calculator says. When we're talking about money and we get something that's even like that, we need to add a 0 to it. So that means $3.70, not 3.7. If you tell me you have $3.7, 90% of the population would look at you like, what? So you add the 0 and then it's $3.70. Now, if it's asking you for the sale price, you've got to take the $18.50 and subtract off the $3.70. If it's asking you for the discount, then you don't need to do that. If it's asking for the discount, you need to just find that $3.70 and you're done. $14.80 will be the sale price. The same thing would apply if you had a tax question. So in a tax question, they can ask you how much is the tax, or they can ask you how much will you pay after the tax has been applied, and they're not the same question. So always watch for that. Number 9 is a scenario 3. If you're totally unfamiliar with commission, you may be at a disadvantage, so I'll explain what it is. Commission is where someone who does sales gets a percentage of the price of whatever they sold. So these could be given in a scenario 2 or 3, but there will never be a second step where we add or subtract something like what we just did on the last problem. You'll never have that. So nobody earns commission and the cost of the item. They only earn commission. So this one is ultimately asking you, what is 6.5% of 9,290. So that makes it a scenario 3 where we take 0.065. Remember that if a percentage only has one digit, you put a 0 in front of it. And that comes from moving it 2 times to the left. So it's 0.065 times 9,290. And that will give me 603.85. That was their only question, is how much does this person get? So they don't get the amount that the company made off the sale and the 6.5, they just get the 6.5%. Number 10 is a scenario 3 as well. It asks about sales tax. So again, sales tax could have 2 aspects to it. It could just ask you for tax, or it could ask you how much the item and the tax will be. This says, what sales tax must you pay? So it's just tax. Ultimately, this becomes a scenario 3, and it comes down to the question, what is 5% of 229? 5% of 229 will be 0.05 times 229, and that will be 1145. The last question on here is a scenario 4. What I'm going to do next is give you a chance to take anything you might have just perfected a little bit and apply it to number 1, 2, 3, and 4 on the next page. It won't take us very long to go through scenario 4. It'll just take us a minute. So I'm going to give you about 5 minutes to do 1, 2, 3, and 4 on the very next page. The very next page says percent applications worksheet 3. And then the one after that says percent applications worksheet 2, because I put them in order of difficulty rather than numerical order. So try those 4 in case you caught anything that will help you. And then I will show you a scenario 4 and give you a couple practices for that. Okay, so the first question is a scenario 3. If you purchase an iPod that costs $339, how much sales tax will you pay? So they just want the tax. That is ultimately a scenario 3 because basically the question is, what is 8.375% of $339? So we take $339 times 0.08375. Never round something like that before you've worked with it. That gives me 28.39125. Keep in mind, this is money, and money is always expressed with 2 places for the change. In this case, we just rounded it down, but always make sure you check because you also might end up rounding it up. The next question is also a 3, and it's a 2-step because it says a shirt that regularly sells for $38.50 is on sale 25% off. By how much is the shirt being discounted? Never mind, it is 1 step because it wants to know the discount. So in other words, what is 25% of $38.50? Now that gives me 9.625. So I need to round to the hundredths place, which is where we always round money. That will make it 9.63. If you said 9.62, you did your process right, and that's definitely a good thing, but you would have missed it. Because trust me, they'll have that there. Number 3 is a scenario 1, and again, they gave you a number of seniors. They asked you for a percentage of seniors. Never count on that happening, but if it does, great. And that will come out to 48%. And number 4 is a scenario 2. It says that they were accurate 90% of the time and then said that they were accurate 45 times. So 45 is 90%. That means that there were 50 days in total. So the last scenario, if we go back to page 1 for just a moment and take a look here, the last scenario will stand out on its own because it's fairly unique in terms of its property. The last one is a percent difference problem. In a percent difference, you're going to be given 2 numbers. And the story that's going to accompany the 2 numbers is essentially going to say, it used to be this and now it's that, or something changed from this to that, or something sort of along those lines. The first thing we need to know is what the difference actually is. You can add a line right here. This is supposed to say difference over divided by original number. I can't make it do that on my computer. So you're going to find the difference between the 2 numbers. The difference is always found by subtracting. Now you want this to be a positive number. So the beauty of this scenario is you don't even have to worry about what number's what. All you need to do is take the bigger number, or one, to get a positive number that represents the difference between the 2. Then we divide by the original number. How do we know which one is the original? The same way we know whether we have a scenario 2 or a scenario 3. We look at the story that's told in the problem and we determine who they said was original. So it's basically where the number would have started. They will ask you to find a percent increase or decrease sometimes. You don't even have to worry about whether it says increase or decrease, because if you use this scenario the way I'm telling you to use it, then it won't matter which one's which, because you'll be able to tell which one is the original. So the original is the place where it started, which means if the original is the bigger number, then you must have a percentage of decrease because the smaller number is the second one. If you have a percent of increase, then the bigger number is the second one, the smaller one's the first. It won't matter because the story will be clear whether you acknowledge which number is bigger or smaller. The story will be clear as to which one is which. So let's go down 2 pages to the one we skipped earlier, which is number 11 on the 3rd page of your packet. It says the cost of paint used in a redecorating job is $65.70. This is a reduction from its original cost of $82.13. What is the percent decrease in the cost of paint to the nearest percent? So you don't need to worry that it says decrease, just worry that you're doing a difference. You'll be able to tell these problems from scenario ones because even though they will always have two different numbers, it will talk about a percentage of change rather than just talking about a percent. So I'm going to use the 82.13 and I'm going to subtract the 65.70 to get the difference. And right now I have not considered which one is original because it doesn't particularly matter. So the difference in a positive number is 1643. The next thing that I want to do is find out which was original. It says right here, this is a reduction from its original cost of $82.13. So it's telling you that it's now priced at $65.70, but originally it had been priced at $82.13. That makes $82.13 the original number. Now, just like a scenario one, all I need to do is divide and turn it into a percentage, and that is a 20% difference. Try out scenario 4 on the next page. So the one that you did 1, 2, 3, and 4, try out scenario 4 on number 8 and on number 10. I will tell you the answers and how to get there in a moment, and then everything else that remains in this packet will be your homework to play around with and get some practice. And then, as I mentioned earlier, there is an advanced math class, and it's designed to be the advanced versions of the geometry. If you're doing TEAS, you need geometry, percentage applications, and ratio and proportion. So those 3 classes all have some really tricky stuff as we near the end, and I combine all the really tricky stuff into one class called Advanced Math. That allows you to get practice on the easier stuff so that you're really good at those basic skills and then move forward and do the harder stuff. So on number 8, you would have started by doing 249 minus 243, and that would have given you 6. So your difference is 6. Last year says that it was 249 compared with 243 being this year. So that will give us 6 over 249, and that is a 2.4% difference. And then we take 15.50 for number 10 and we subtract 14. So our difference is $1.50. Our original is 14. So we take $1.50, we divide it by 14, and we get 10.7%. You may end up rounding that up to 11%, but your answer choices will make that determination, so you don't know right away whether it's one or the other. That is it for percent applications. When you hit the last few pages of this packet, they are trickier. So if you bump into the last few pages and you have any trouble, just keep in mind that advanced math is designed for that. You are more than welcome to try them, of course. And then that is it. So let me know if you have questions, and I will see you guys later. Thanks.